मित्रांनो, स्वागत आहे तुमचे माझ्या यूट्यूब चॅनलमध्ये. आज आपण इंजिनिअरिंग व डिप्लोमाच्या प्रथम वर्षातील विषयाबद्दल बोलणार आहोत. बेसिक्स ऑफ इलेक्ट्रिकल इंजिनिअरिंग किंवा फंडामेंटल्स ऑफ इलेक्ट्रिकल इंजिनिअरिंग हा विषय आपल्याला माहिती आहे. आजच्या व्हिडिओमध्ये आपण थेरी एक्झाम म्हणजेच लेखी परीक्षा यामध्ये विचारल्या जाणाऱ्या प्रश्नांबद्दल जाणून घेऊया. सदरचे प्रश्न ओरल एक्झाम म्हणजेच तोंडी परीक्षेत देखील विचारले जातात. या व्हिडिओमध्ये इलेक्ट्रिकल इंजिनिअरिंगचे बेसिक कन्सेप्ट्स असल्यामुळे MPSC, UPSC, रेल्वे, PWD, MSCBचे 3 विभाग जसे की जनरेशन, ट्रान्समिशन अँड डिस्ट्रीब्युशन, गेटच्या परीक्षेची तयारी करणाऱ्या विद्यार्थ्यांसाठी उपयुक्त आहे. सदर प्रश्न उत्तरे हे व्हिडिओ ऑडिओच्या स्वरूपात असल्याने तुम्ही मोकळ्या वेळेत हेडफोनचा वापर करून ऐकू शकतात. चला तर मग व्हिडिओची सुरुवात करूया. डिफाईन करंट अँड स्टेट इट्स युनिट. करंट इज डिफाइंड ॲज फ्लो ऑफ इलेक्ट्रॉन्स inside the conducting material. Its unit is ampere. Define EMF and state its unit. It is electrical pressure or potential difference which causes movement of electrons inside the conducting material. Its unit is volts. Define potential difference and state its unit. The difference between the electric potentials at any two given points in the electrical circuit is known as potential difference. Its unit is volt. Define 1 volt. It is potential difference across a resistance of 1 ohm carrying a current of 1 ampere. Define 1 ampere. A current of 1 ampere is said to be flowing if a charge of 1 coulomb passes given any point in a conductor in 1 second. Define resistance and state its unit. Resistance is defined as the property of a substance due to which it opposes or restricts the flow of current through it. Its unit is ohm. Define resistivity and state its unit. The specific resistance of a material or resistivity is defined as the resistance of the piece of that material which have unit length and unit cross sectional area. Its unit is ohm meter. Define temperature coefficient of resistance. The temperature coefficient of a material may be defined as the increase in resistance per ohm original resistance per degree Celsius rise in temperature. Its unit is per degree Celsius. Define conductance and state its unit. Conductance is defined as the reciprocal of resistance. Its unit is ohm inverse or Siemens or mho. Define electric work and state its unit. An electric work is the work done to transfer a charge from one point to the other. Its unit is joules. Define power and state its unit. It is defined as the rate of doing work. Its unit is watt. Define energy and state its unit. It is defined as the capacity of doing work. Its unit is watt hour or kilowatt hour or megawatt hour. List the different types of resistors. The resistors are classified into three types. First, fixed resistors. Second, variable resistors. Third, non-linear resistors. The various types of resistors are carbon composition, deposited carbon, high voltage ink film, metal film, metal glaze, wire wound, and cermet. State the different effects of electric current. First effect, heating effect of electric current. Second, chemical effect of electric current. And third, magnetic effect of electric current. State Ohm's law applied for electric circuit. The ratio of potential difference between any 2 points on a conductor to the current flowing between them is constant provided the temperature of the conductor does not change. Define internal resistance of source. Opposition offered by electrolyte to the current within the battery is called internal resistance. Define terminal voltage. The voltage available at the output terminal of a cell or DC generator is known as terminal voltage. State Kirchhoff's current law. The algebraic sum of all currents entering or leaving a node must be equal to 0. State Kirchhoff's voltage law. It states that the algebraic sum of the voltage around a closed loop in a circuit must be equal to 0. Define linear circuit. It is the circuit whose parameters are constant, that is, they do not changes with voltage or current. Define non-linear circuit. It is the circuit whose parameters changes with voltage or current. Define bilateral circuit. It is the circuit whose properties or characteristics are same in both direction. Its example, transmission line. Define unilateral circuit. It is the circuit whose properties or characteristics changes with the direction of its operation. Its example, diode. Define electric network. A combination of various electric elements connected in any manner is called as electric network. Define active network. It is that network which contains one or more than one source of EMF. Define passive network. It is that network which contains no source of EMF. Define node. It is a junction in a circuit where two or more circuit elements are connected together. Define branch. It is that part of a network which lies between two junctions. Define loop. It is closed path in a circuit in which no element or node is encountered more than once. Define mesh. It is a loop that contains no other loop within it. Define capacitor. A capacitor essentially consists of two conducting surfaces separated by a layer of an insulating medium called dielectric. The purpose of capacitor is to store electrical energy by electrostatic stress in the dielectric. Define capacitance and state its unit. It is defined as the property of capacitor to store electricity. Its unit is farad or coulomb per volt. Define dielectric strength and state its unit. It is defined as the property of insulating medium which enables it to withstand continuous electric stress without breaking down. Its unit is kilovolt per centimeter. Define breakdown voltage. It is the maximum voltage which can be applied across the capacitor plates without breakdown of the dielectric medium. Define dielectric loss and state its unit. When a capacitor is connected to AC voltage, the dielectric between the conducting plates of capacitor consumes some power. The power taken by dielectric is called dielectric loss. Its unit is watt. List various types of capacitors: paper capacitor, mica capacitor, plastic film capacitor, ceramic capacitor, glass capacitor, electrolytic capacitor, air capacitor. Define electric flux and state its unit. It is defined as the number of lines of force in any particular electric field. Its unit is coulombs. Define flux density and state its unit. It is defined as the flux per unit area at right angles to the direction of the electric flux. Its unit is coulomb per square meter. Define electric field strength or field intensity. It is defined as the mechanical force experienced by a unit positive charge when it is placed at any point in the electric field. Its unit is Newton per coulomb or Volt per meter. Define permittivity and state its unit. The permittivity is defined as the ease with which a dielectric material acting as a medium allow the electric flux to be established in it. Define magnetic circuit. The closed path followed by magnetic flux is called magnetic circuit. Define magnetomotive force. It is defined as the total force acting in the magnetic circuit which drives the flux through the circuit. Define reluctance. Reluctance is the opposition offered by the material to the flow of magnetic flux through it. Define permeance. It is the reciprocal of reluctance and permits the flow of magnetic flux through magnetic circuit. Define flux density and state its unit. The flux per unit area in a plane at right angles to the flux is known as flux density. Its unit is Tesla. Define magnetic field strength and state its unit. It is defined as force acting in magnetic circuit per meter length of magnetic circuit which drives the flux in the circuit forward. Its unit is ampere per meter. State Ohm's law applied for magnetic circuit. Flux is directly proportional to mmf and inversely proportional to the reluctance of the magnetic path. Define magnetic hysteresis. When a magnetic material is subjected to a cycle of magnetization, it is found that flux density in the magnetic material lags behind the applied magnetizing force. This phenomenon is known as magnetic hysteresis. Define hysteresis loss. When a magnetic material is subjected to a cycle of magnetization, an energy loss takes place due to the molecular friction in the material. This loss in the form of heat and is called as hysteresis loss. Define magnetic flux. The total number of lines of force in a magnetic field is known as magnetic flux. Its unit is Weber. Define useful flux. The flux which is available at the air gap and can be utilized for some useful purpose is called as useful flux. Define leakage flux. The flux which completes its path through air or medium surrounding the magnetic circuit instead of completing it through the core and air gap. Define magnetic fringing. The tendency of magnetic flux to spread out at the edges of the air gap is known as magnetic fringing. State Faraday's first law of electromagnetic induction. Whenever a changing magnetic flux is linking with a circuit, EMF is induced in the circuit, or whenever a conductor cuts the magnetic flux, an EMF is induced in it. State Faraday's second law of electromagnetic induction. It states that the magnitude of the induced EMF is equal to the rate of change of flux linkages. State Lenz's law. This law states that direction of induced EMF is always such that it opposes the very cause of its production. Define self-inductance and state its unit. The property of the coil to oppose any change in current flowing through it is known as the self-inductance. Its unit is Henry. Define mutual inductance. It is defined as the property due to which one coil with the change in its own current produces an EMF in a nearby coil by induction. State the different types of induced EMF. First, statically induced EMF, in which mutually induced EMF and self-induced EMF. Second type, dynamically induced EMF. Define coefficient of coupling. It is defined as the ratio of the actual mutual inductance present between the two coils to its maximum possible value. State Fleming's right hand rule. Hold out the right hand with the first finger, middle finger and thumb at right angles to each other. If first finger represents the direction of magnetic lines of force, the thumb points in the direction of motion, then middle finger points in the direction of induced EMF. State the application of lead acid battery. First, railway train lighting system. Second, automobiles. Third, telephone exchanges, broadcasting. Fourth, power stations and distribution substations for lighting and switch gears. Fifth, emergency light supply in hospitals, shops and banks. Define cycle. One complete set of positive and negative values of an alternating quantity is known as cycle. Define frequency. The number of cycles completed by alternating quantity in 1 second is called as frequency. Define amplitude. The maximum value attained by alternating quantity during either positive half cycle or negative half cycle is called its amplitude. Define time period. The time taken by alternating quantity to complete one cycle is called its time period. State the classification of insulating materials. First, solid insulator. Second, liquid insulator. Third, gaseous insulator. State the classification of electrical materials. First, conducting material. Second, insulating material. Third, magnetic material. State the classification of magnetic materials. First, diamagnetic. Second, paramagnetic. Third, ferromagnetic. State the applications of magnetic materials. Electric motors, electric generators, CD-ROMs, DVD-ROMs, etc. State the various types of inductors. First, iron core inductor. Second, air core inductor. Third, ferrite core inductor. State the properties of good insulating materials. First, resistivity should be very high. Second, it should be water resistant. Third, it should not contain impurities. Fourth, not affected by chemical process. Fifth, it should be heat resistant and fireproof. Sixth, it should be mechanically strong. 7. It should be not porous. State the applications of electromagnets. First, as field and armature in DC machines. Second, in cores of solenoid valves. Third, in cores of electromechanical relays. Fourth, in electromagnetic circuits of all AC machines. Fifth, electrical measuring instruments. Sixth, core of transformers. State the applications of electrolytic capacitors. First, decoupling or noise filtering in power supplies. Second, DC link circuits in variable frequency drives. Third, coupling capacitor in amplifiers. Fourth, energy storage in flash lamps. State the applications of storage batteries. First, broadcasting stations. Second, transmission and distribution substations. Third, telephone and telegraphic services. Fourth, emergency lighting for hospitals, shops, banks, etc. Fifth, automobiles. Six, solar street lights. 7. Railway signaling system. State the applications of CRGO silicon steel. First, manufacturing of distribution and power transformer cores. Second, manufacturing cores of audio transformers, ballast transformers. Third, manufacturing cores of large transformers, generators and motors. Fourth, manufacturing of stator and rotor of water wheel generators and turbo generator. State the applications of HRGO silicon steel. First, manufacturing cores of small rating transformers. Second, manufacturing cores of small rating induction motors. Third, manufacturing of water wheel generators and turbo generator. State the applications of amorphous materials. First, manufacturing of magnetic sensors. Second, manufacturing of magnetomotive sensors. Third, manufacturing of special transformer cores. Fourth, manufacturing cores of high efficiency distribution transformers. Fifth, making nanocomposites for field electron emission devices. State the applications of bronze. First, making brush holders. Second, making knife switch blades. Third, making current carrying springs and bushings. Fourth, cadmium bronze is used for making commutator segments and contact wires. State the materials used for conductor and insulator. Material used for current conductors are silver, copper, aluminum, steel, brass and bronze. Materials used for insulators are mica, PVC, rubber, glass, paper, porcelain, etc. Define coefficient of self-inductance. Coefficient of self-inductance of a coil is defined as the ratio of the electromotive force produced in a coil by self-induction to the rate of change of current producing it. Define Coefficient of mutual inductance. Coefficient of mutual inductance of a coil is defined as the ratio of the electromotive force produced in a coil by mutual induction to the rate of change of current in another coil producing it. State the applications of air core inductors and iron core inductors. First, air core inductors. High frequency applications such as radio sets, wave traps, induction heaters, etc. Second, iron core inductors. Low frequency applications, filters, chokes, amplifiers and other DC applications. State the applications of permanent magnet. First, field of DC motors. Second, tacho generators. Third, stepper motors. Fourth, field of two-wheeler and car dynamo. Fifth, magnetic therapy. Sixth, magnetic compass. 7. Telephones and microphones. 8. Small toys. 9. Earphones and permanent magnet moving coil instruments. तुम्हाला अजून काही प्रश्न असतील तर कमेंटमध्ये नक्की विचारा. हा व्हिडिओ जास्तीत जास्त शेअर करा. व्हिडिओ आवडला असेल तर व्हिडिओला लाईक करा. चॅनलवर नवीन असाल तर चॅनलला सबस्क्राईब करा. धन्यवाद.